Okay, guys, so we're still on page 5, and we did this one last video, so we're gonna do numbers 2 and 3. So find all local maximums for the function below. And we talked about this before, a local extrema, there could be many of them. They're just like the highest points within like an open interval around it. So relative to all the points around them, to the left and right of them, they are the highest. Maybe not overall, but relative to the ones near them, they are. Okay, and we're doing a max. All right, so guys, I'm gonna do this little sequence, and when you're doing a derivative sequence for graph facts, we won't use the second derivative just yet, but I would include an x column as well. Okay, so this is probably too long. All right, so maximums, minimums, all right, any sort of graph facts like this. Our first move is going to be to find the critical numbers of f, of this f here. The critical numbers are like critical meaning important. Like, so these are the numbers where an important change on the graph of f might be happening. And you will observe an important change on the graph of f if its derivative f prime is 0 or undefined. Okay, so my very first move is going to be to take the derivative. So f prime of x equals -2. Okay, and then to find out where this is 0 or undefined, you're going to have to factor it. So I'm going to represent this derivative in factored form. Okay. Alrighty, so this is the derivative. This is f prime in factored form. So this is never undefined because I don't have a denominator. And it's 0 at 0, 5, and 9. So 0, 5, and 9. Those are the critical numbers. Okay. Now, what am I looking for? I'm looking for local maximums. So a local max on f. So let me put max right there. Okay. What's going to be true if f has a max? F prime is going to have to change. It's going to have a sign change, and specifically, it has to go from positive to negative. Guys, if you're ever looking for any kind of sign or sign change, you're going to need a number line. Okay, if you're looking for a sign or a sign change, you're going to need a number line. Okay, so I'm going to go to this number line. This is the number, so I need the number line. I'm in the f prime column. So this is going to represent positive and negative values of f prime. Then I'm going to take my critical numbers and put them in order here. Okay. So right now, we've got 1, 2, 3, we've got 4 sections to this number line. And we're going to plug in a testing point from each section into the derivative and see if we get a positive or a negative outcome. Okay, so testing points. I'll choose a different color. All right, so let me plug in, I'll plug in -1, 1, 6, and 10. Okay, so all right, so I've got this, I've got 1, 2, basically these 3 factors that I'm going to be plugging into. So 1, 2, 3. So I'm just going to test the signs. So if I plug -1 in here, I'm going to get a negative. If I plug it in here, a negative, plug it in there, a negative. Negative times negative times negative is a negative. Okay, so on that entire interval, f prime is negative. Okay, now I'm going to do it for 1. And guys, I want to make this observation real quick. So x squared is always positive. Negative 2 is always negative. So whatever you plug in for this x, you're going to end up here with a negative outcome because it would be this negative 2 times a positive number. All right, so that's going to be negative all the time. So if you plug 1 in, it's negative. Plug it in there, negative, and again negative. Okay, so minus. So there was not a sign change at this critical number. All right, now we're plugging in 6. Plugging in 6, I'm getting a negative, positive, negative, positive. Then we're plugging in 10, negative, positive, positive, negative. Okay, guys, we're looking for a positive to negative sign change. All right, here there's no sign change. Here, negative to positive. Here is where we've got positive to negative. Oh, and by the way, guys, I should have put zeros, I think, above those because f prime is 0 at those values. Okay, so out of all 3 of these critical numbers, 9 is the one at which f will have a max. Now, guys, the answer, though, is not 9. If they asked at which value does f have a maximum, at which value, then it would be 9. But if they're asking for the max, they want to know the y value. So I'm going to take 9 and I'm going to, if I just go f of 9, that's going to give me my max. Okay. So, wow, that's a big number. Find all local maximums. All right, so I'm going to have to use a calculator here. Okay, so plugging in 9. Alrighty, so if they asked at which x value does the local max occur, then we would be done. All right. Oh, guys, here, this will be easy. Let me use the table. So I'm going to go to y equals negative 2/5 x to the 5th All right, and then table set, it is on ask, so I go to the table and I could just hit 9. And then if I hover over it, then you would see the whole decimal. So 476.4. All right, so f local max f of 9 equals 476.4. Okay, so there we go. Alrighty, now find all intervals over which the following function is decreasing. Okay, so it's going to start the same, which is looking for critical numbers. Critical numbers are where the first derivative is 0 or undefined. Okay, so let me find them. So f prime of x Okay, so f prime of x is 3x. Shoot, what is that? Minus 9, x plus 6. Okay, so my critical numbers, so when is this 0? For 0, 9, and negative 6. So those are going to be the points that we put on the number line. And why do we need a number line? Let's talk about that. So find all intervals over which the following function is decreasing. So I want f to be decreasing. For f to be decreasing, you have to know your graph facts. What does that mean about f prime? Negative. And guys, once again, if you need a sign, like a negative, or a sign change, like before, we need a number line, okay? If you're looking for a sign or a sign change, you need a number line. Okay, so we're gonna take a number line, label it f prime, put your critical numbers on there in order, be careful, so -6, 0, and 9. Oh, and I'll put zeros above because at those values, f prime is 0. And now we need testing points. So I'll do -7, -1, 1, and 10. All right. And then I'll look at this as one factor. Okay, so I have these 3 factors, and I'm going to plug each of those in and do a sign test. And I have to do it 4 times. You know, I like setting stuff up like that. All right, so that's going to be sign. All of our little sign tests. Okay, so -7 goes in here. We get a negative, 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 negative. Okay, let me just go through and get all the signs. So -1 goes in, negative, negative, positive. Negative, negative, positive. 1 goes in, positive, negative, positive. And then 10 goes in, and everything is positive. Okay, so for these ones, negative outcome. Here, positive outcome. Here, negative outcome. There, positive outcome. So what were we looking for? We were looking for negative outcomes on the f prime number line. And I see that my solution, so my negative intervals are right here, from -infinity up to -6, and then right here between 0 and 9. All right, so I'll just write it in here. So this is an x, this is not an x value, it's an interval. 0 to 9, okay? And then I'll just write it nicely. So decreasing, so f is decreasing on -infinity to -6, union 0 to 9. Okay, guys, there it is.